I want to tell you a story about building something most people said was impossible, because that's usually where the interesting work begins, and this time it's about xAI, and why we just acquired a third building near Memphis to expand our computing infrastructure, because intelligence at scale is ultimately a physics problem, not just a software one. And if you want to compete with the biggest AI players on Earth, you need to think in terms of power, cooling, silicon, networking, and time, not just models and hype. So when I started xAI, the goal was never to make another chatbot that politely agrees with you. The goal was to build an AI that actually understands the universe, that seeks truth even when it's uncomfortable. And to do that, you need an absurd amount of compute, far more than people realize, which is why we made the decision early on to build our own supercomputer cluster, instead of waiting in line for someone else's capacity. And Memphis became the center of gravity for that vision, because it offered the scale, the energy access, and the logistical reality needed to move fast. And when I say fast, I mean bending timelines that normally take years into months, sometimes weeks. And that's why acquiring a third building wasn't a vanity move or a press headline. It was a necessity driven by exponential curves, because every new generation of model demands orders of magnitude, more compute, more memory bandwidth, more interconnect density, and tighter integration between hardware and software. And people often underestimate how brutal those requirements are until they try to build it themselves, which we did rack by rack, transformer by transformer, cooling system by cooling system, pushing power limits that most data centers were never designed to handle. And yes, it's noisy, it's hot, it's expensive, but that's what progress looks like when you're actually doing the work instead of talking about it. And the idea is simple, even if the execution is not. Build one of the most powerful AI training clusters in the world, scale it rapidly, and use it to train systems that are not just bigger, but more aligned with reality, more curious, more honest, because intelligence divorced from truth is just another form of noise. And I've seen what happens when systems optimize for engagement instead of understanding. And that's not the future we want. So this expansion near Memphis is about sovereignty over our own destiny in AI. It's about not being bottlenecked by external providers. It's about owning the full stack, from electrons to algorithms. And when you walk through these buildings, you can feel it. The hum of thousands of GPUs synchronized like a single machine. The sense that something alive is being built, something that will eventually help us answer fundamental questions about the universe, about consciousness, about what it means to be human in an age of artificial intelligence. And I know some people look at this and see risk or ambition or ego, but what I see is responsibility. Because if AI is going to shape civilization, then the people building it need to be willing to go all in, to take massive bets, to move faster than comfort allows, and to do it transparently. And that's why this third building matters, not as a structure of steel and concrete, but as another step toward building an AI system powerful enough to be useful, honest enough to be trusted, and scalable enough to matter. And we're just getting started, because when you're chasing the truth, there is no finish line, only the next expansion. I want to go deeper into why this expansion isn't just about scale, but about control, resilience, and accelerating the feedback loop between discovery and deployment. Because when you're operating at the frontier of intelligence, you don't get the luxury of slow iteration. Every bottleneck compounds, every delay costs insight, and every constraint shapes the kind of intelligence you end up with. So as we expanded to a third building near Memphis, the real challenge wasn't signing papers or moving equipment. It was synchronizing an entire ecosystem of power generation, cooling architecture, high-speed networking, and software orchestration so that the whole thing behaves like a single organism instead of a pile of machines. And that's a non-trivial problem because once you cross a certain threshold of compute, latency becomes philosophy, not engineering. Nanoseconds matter, packet loss matters, thermal gradients matter, and the models themselves start to behave differently when you give them enough capacity to actually reason instead of approximate. And that's where things get interesting because you stop tuning for tricks and start discovering emergent behavior, patterns that weren't explicitly programmed but arise naturally from scale and structure. And those moments are why we do this, because they hint at something deeper than optimization, something closer to understanding. And to get there, we needed more space, more power, more redundancy, more freedom to experiment without asking permission. And Memphis gave us that runway. And I know people ask, why not just rent more cloud capacity? Why take on the burden of physical infrastructure? And the answer is simple, because true innovation happens when hardware and software co-evolve, when you can redesign the system end to end instead of inheriting someone else's assumptions. And this third building is effectively a laboratory for that philosophy, a place where we can test new training regimes, new interconnect topologies, new ways of managing failure at scale. Because failure is inevitable when you push limits. The question is whether your system collapses or learns, and we design ours to learn. And as we continue building out this cluster, the goal is not just to match existing AI supercomputers, but to surpass them in efficiency, adaptability, and truth-seeking capability. Because raw flops alone don't give you wisdom, they just give you potential. And it's how you channel that potential that determines the outcome. And I think a lot of the future of civilization will depend on whether AI systems are trained to reinforce existing narratives or to question them, to flatter us or to challenge us, to obscure reality or to clarify it. And xAI is built around the idea that clarity matters more than comfort, and that's why this expansion matters on a philosophical level. Because infrastructure is ideology made physical. It reflects what you believe the future should be, and by investing this heavily, this fast, and this deliberately, we're saying that the future of AI should be open to scrutiny, grounded in reality, and powerful enough to actually help humanity navigate what's coming next. And again, this is not the end of the story. It's just another inflection point, because once you see what's possible when constraints are removed, you realize the real limitation was never compute or buildings or power, it was imagination. And that's the one thing we refuse to scale conservatively. The moment it really clicked for me that this wasn't just another company or another infrastructure build, but a turning point in how intelligence itself would be created. Because when you stand inside a facility like this, surrounded by machines that are collectively performing more operations per second than the human brain can even intuitively grasp, you realize that we're no longer just writing code, we're shaping an environment in which intelligence can emerge. And that's a profound responsibility. So, expanding into a third building near Memphis wasn't just about fitting more GPUs or increasing headline numbers. It was about designing an ecosystem that could sustain long-term exploration without collapsing under its own complexity, because complexity is the silent killer of ambitious systems, and if you don't architect for it from the start, it will eat you alive. So we obsessed over redundancy, fault tolerance, energy buffering, thermal equilibrium, and network topology in ways that might seem excessive until something breaks at scale and you realize that the difference between minutes and milliseconds can decide whether a training run survives or fails. And people often don't see this side of AI. They see demos and interfaces and outputs, but underneath all of that is a relentless physical process. Electrons moving through copper and silicon, heat being pulled away, molecule by molecule, signals racing across fibers, and all of it has to work in harmony or nothing works at all. And what excites me is that by owning this infrastructure, we're not just reacting to the limits of today's hardware. We're actively informing what the next generation should look like. Because when software demands something strongly enough, hardware eventually follows, and we're already seeing that feedback loop tighten. And the third building gives us the freedom to push harder, to run experiments that are inefficient today, but unlock orders of magnitude improvements tomorrow. And that's how breakthroughs actually happen, not by optimizing the last 5%, but by changing the shape of the problem entirely. And philosophically, this matters because intelligence is not static. It evolves based on the constraints and incentives you give it. And by building a system that prioritizes truth-seeking over conformity, robustness over polish, and understanding over imitation, we're trying to create an AI that doesn't just mirror humanity, but helps us see ourselves more clearly. And I know that sounds abstract, but it becomes very concrete when you're deciding how to allocate megawatts of power, or how to schedule trillion parameter training runs, because every one of those decisions encodes values, whether you admit it or not.